We've got a circle geometry question this time, and we're told that we've got a circle with the centre 5, 8, just touches the y-axis. That's interesting, isn't it? Because that means that actually we know that distance, because that x value is 5 and the y value is 8. We know this distance across here must be 5, which happens to be the radius of the circle. Without even reading the question. Part A, express the equation of the circle in the form. Okay, so we know that the centre of the circle is at 5, 8, and we know that this has to be the radius squared, which is going to be 25. So nice easy starter. X take away 5 all squared plus y take away 8 all squared is equal to 25. If you're really keen, is equal to 5 squared. Okay. Part B, verify that the point 212 lies on the circle. Easiest way to do this is to just take those values, stick them into our equation, and hopefully it'll work out. If it does, then we're good. If it doesn't, we know that something's gone wrong or it's not on the circle. Okay, so x is 2, so we've got 2 take away 5 squared plus y is 12, so 12 take away 8 squared hopefully should make 25. Let's check. 2 take away 5 is 3, so it's 3 squared, which is 9, plus 12 take away 8, which is 4, so it's 4 squared, which is 16. When we add them together, it does in fact make 25, so we can even write the point lies on the circle. Part B, find an equation of the tangent to the circle at the point A. Where's A? It's that same point that we've just been looking at. Let's just get a feel for what's going on here. It's the point A, which has got the coordinates 2, 12. So we know that this was 5, 8. So the point 2, 12 is probably going to be 2, not as far as 5, but up further. So we're probably looking at the point A is somewhere up there. So we're expecting the gradient of that line to be negative to 12, and because we're doing a tangent, we'd expect the gradient of the tangent to be positive. How do we find the gradient of this line? Because we're looking at getting the equation of the tangent. So the gradient of this line, difference in y divided by difference in x. Okay, so we've got 8 take away 12, difference in y values, divided by the difference in the x values, which is 5 take away 2. 8 take away 12 is minus 4. 5 take away 2 is 3. So that's the gradient of the radius, or the normal to the circle. So the gradient of the tangent will be equal to negative reciprocal of that. Let's just write that down in case we get points for it. It's going to be equal to 3 over 4. Okay, what else do we know? We know it goes through the point A, which is at 2, 12. So we're busy thinking about y equals mx plus c. Putting the m in, we've got y is equal to 3/4 x plus c. I'm going to multiply up by the 4 at this point because I know that I want all whole numbers anyway. So we can say 4y is equal to 3x plus 4c. Let's now put in the y and the x values. 4 times 12 is 48, is equal to 3 times 2, which is 6 plus 4c. So 4c must be equal to 48. Take away the 6, must be equal to 42. 6 plus 42 makes 48. At this point, I'm not even going to bother dividing, because I know that I'm trying to go for these whole number things anyway. So going back to this line here, we can now actually start rewriting that. 4y is equal to 3x plus 4c, which was 42. Getting it all equal to 0 by moving the 4y over. 0 is equal to 3x. Take away 4y plus 42. Let's just at this point check the mark scheme. We're saying that s is 3, t is minus 4, and u is 42. Let's have a little look. Here we are. Aha, 3x minus 4y plus 42. We can see we've got the final answer. Would we have got those points? There's our gradient of that normal, or the radius, minus 4/3 for 1 mark. Gradient of tangent, 3/4, negative reciprocal. Or just do a negative reciprocal on whatever you made the gradient there, still gets you 1 mark. At this point, we are attempting to find c using x is 2 and y is 12. Yeah, we definitely did that. We had something like that. We actually had better than that. We had it in a better form, and there's our final answer. Just checking back for the first couple of points. X minus 5, so 1 mark here for the put in the coordinates of the centre, second mark for the radius of 25. We're allowed to have 5 squared. Again, that B part I is checking that A does lie in a circle. Yeah, we have the 9 plus 16 does make 25. There's that statement, concluding statement, must have a concluding statement. Okay, so just make sure you include those bits. Don't lose easy marks because you've done all the work anyway. Okay, at this point I will give you your question as your evidence that you've watched the video. Please can you bring in, or please can you tell me, can you differentiate 3x to the power of 5? Differentiate 3x to the power of 5. Okay, so we are now on to part C. The points P and Q lie on the circle, and the midpoint of P to Q is M, which is at 7, 12. So remembering that that was at 5, 7's probably here, and so our midpoint is probably about there. Maybe it's P and Q are looking something like that. Okay, let's go for this one can be P, this one can be Q. Okay, we do know we're going to have a nice right-angled triangle there, don't we? Okay, other things we know about that triangle, we know that the radius is 5, so we can say that that's 5. There's our right angle. I wonder what that distance there is. Well, we can work it out, can't we? Because we know that the value here is 5, 8, and we know that the value here, the coordinate here, is 7, 12. So actually on that line there, we can even do Pythagoras on that line there. Difference in the x coordinates between 5 and 7 is 2. Difference in the y coordinates, 8 to 12 is 4. So the length of our line there, the length of C to M, show that the length of C to M, we're going to get something root 5. C to M is going to be 2 squared. Well, C to M squared is going to be 2 squared plus 4 squared. So that's going to be equal to 4 plus 16, here we go, is 20. So that's C to M squared. So C to M is going to be root 20, which is root 4 root 5, which is 2 root 5. Happy there. I don't think we even need to check the mark scheme because we've got it as something root 5. Next part, hence find the area of the triangle PCQ. Now think about this a little bit carefully. We're not thinking about that triangle there. We're not thinking about that one. We're thinking about the whole triangle PCQ, which is actually double this triangle here. So one thing we might like to do is to get half of that triangle and then double it. To do that, well, what do we know? We need the two sides which have got the right angle between them. We've got one of them now, and we also know the other one. So we can do Pythagoras on this again to get that last missing side. So 5 squared, take away 20, because it was 2 root 5 or root 20, and when we square it, we've got 20. So that gives us 25 take away 20, which equals 5. And that, of course, was that midpoint M to P squared. So M to P just on its own is root 5. Okay, to get the area of that whole triangle, we're going to take the area of this single triangle and we're going to double it. The area of the single triangle will be 2 root 5 divided by 2. But then because we're doubling it, we're going to times it by 2 afterwards. So you can probably see that the root, or the divide by 2 times by 2 is going to cancel. Okay, so the area of our triangle PCQ is going to be equal to 2 times root 5 times root 5, which is 5, which is equal to 10. That's our area of the triangle. Let's just check the mark scheme. So where were we? We have got our area of 10. PCQ was root 5 times 2 root 5. Did we work out P to M properly? Yeah, we had one length. We were doing Pythagoras, but subtracting. 25 take away 20. Pythagoras used correctly. Gave us P to M as root 5. Looking back further, did we work out C to M properly? Well, we were kind of confident on that one because it was of the right format. Difference in the x values plus difference in the y values, that gave us cm squared. Note that they do like it in that format, so that it just makes it a whole lot easier for you, and then just square rooting at the end. So there's another question for you.